Welcome to Dr. CM Edcast, your go-to resource for medical learning. Through discussions, case studies, tutorials, and debates, we help you learn, grow, serve.
Have you ever really stopped to think about what happens after you take a bite of food? I mean, it seems so simple, right? But that one single act kicks off this incredible, really complex biological journey through your body. So let's dive into this amazing process, starting from the very, very beginning. Okay, let's trace the path right here on this diagram. We're starting at the top, of course, with the mouth. That leads down that long tube, the esophagus, and then it lands us in that J-shaped powerhouse, the stomach. Think of this as our roadmap for the journey ahead, just the first leg of a much longer trip. You know, it's so much more than just dropping food down a tube. Not at all. It's actually a highly coordinated symphony of mechanical and chemical events, all designed to turn that bite of food into fuel for your body. So let's follow that food and find out exactly what's going on. Our first destination is, of course, the mouth, the official gateway to the entire digestive system. This is where the real work kicks off, with two different kinds of breakdown happening at the exact same time. It's pretty cool. So the first action has a fancy name, mastication. But that's really just the scientific term for chewing. And while it's something you consciously decide to do, it is an absolutely essential first step. It's all about physically smashing that food into a much more manageable form. Now, what's really interesting here is that chewing does so much more than just crush things up. By breaking food into smaller bits, you're massively increasing the surface area for enzymes to get to work on later. It also, prevents you from scratching up your insides, and it gets the food thoroughly mixed with our first major chemical agent, saliva. So, we've covered the mechanical part, the crushing, but the mouth is also a pretty sophisticated chemical lab. And the key ingredient here is saliva, which, believe me, is so much more than just water. And this just shows you exactly where that saliva comes from. On the left, you can see the major salivary glands. And get this, together they pump out about 1.5 liters of this stuff every single day. And that graph on the right is fascinating. Don't worry about all the numbers. Just notice how the composition lines change as the flow rate on the bottom increases. It shows that its chemical makeup isn't constant, it actually adapts. So the bottom line is that saliva is an absolute powerhouse. It's got an enzyme called amylase to start breaking down starches right there in your mouth. It has mucus to lubricate the food into a slippery ball we call a bolus. It even has antibacterial agents like lysozyme and IgA that act as a first line of defense. It's a true multi-purpose fluid. All right, so the food is now chewed up and perfectly mixed into a bolus. Now for the next critical step, the journey down. This is called deglutition, or just swallowing. And it's a remarkably complex reflex that starts off as voluntary, but then quickly becomes completely automatic. Let's break this down. First up is the voluntary oral phase. That's you using your tongue to push the food to the back of your throat. That action triggers the involuntary pharyngeal phase. And this is an amazing bit of biological engineering. Your soft palate shoots up to block your nose, and this little flap called the epiglottis slams down like a trapdoor to protect your windpipe. Finally, the esophageal phase kicks in, and muscular contractions just take over, pushing the food down. And listen to this. That whole intricate, life-saving process of protecting your airway, it happens in just 1 to 2 seconds. It is an incredibly fast and precise reflex to make sure food goes down the right pipe, every single time. After its quick trip down the esophagus, the bolus arrives at its next major destination. Welcome to the stomach. Now, you need to stop thinking of this as just a passive storage bag. It's not. It's a dynamic, muscular, chemical reactor. And when I say chemical reactor, I am not kidding. This number, 3 million, that's roughly how many times more acidic the juice in your stomach is compared to your own blood. It is an unbelievably harsh environment, and it's created that way by design. So how in the world does it get that acidic? Let's zoom in on the microscopic machinery in this diagram. Find the cell labeled parietal cell. See that thing inside it called a proton pump? It is actively, literally pushing hydrogen ions out into the stomach, where they combine with chloride to form incredibly powerful hydrochloric acid. But it's not just acid. Let's look at the full cocktail here. You've got the hydrochloric acid to kill germs and unravel proteins. You've got pepsinogen, which gets switched on by the acid to become pepsin and start digesting proteins. And maybe most importantly, you have this thick layer of mucus to protect the stomach lining from digesting itself. It's a perfect example of controlled power. So, the chemical bath is ready. Now, the stomach needs to physically mix everything up. Its powerful muscular walls are designed for exactly that purpose. And this diagram illustrates how it works perfectly. The stomach generates these really powerful mixing waves that push the contents toward the exit. But here's the trick. The exit, that pyloric sphincter, is mostly closed. So as the wave hits it, most of the food is squirted backwards in a process called retropulsion. It's like a biological washing machine, just churning and churning to make sure everything gets turned into a paste we call chyme.
Now, once that chyme is ready, the stomach doesn't just dump it all out at once. No, the release is very carefully regulated. As you can see here, things like liquids or carbs can speed it up, but a meal that's high in fat or protein, or if there's high acidity in the next part of the intestine, that signals the stomach to slow things right down. The body is pacing itself for the next stage.
So, a little bit at a time, that perfectly mixed and acidified chyme is passed through the pyloric sphincter. That's the exit valve you see at the bottom of the stomach here, and into the small intestine. The journey through the upper digestive tract is now complete. That first major transformation is done. So we've gone from a solid bite to a semi-liquid paste, and we've started the breakdown of starches and proteins along the way. But the job is far from over. I mean, that highly acidic chyme is about to enter a completely new environment that needs to neutralize it and tackle fats and more complex molecules. So what new chemical challenges await in the next stage? Well, that's a story for another explainer.